Um, so yeah, this is our STAT430 project presentation. My name is Nate.
And I'm Matthew.
Right. And our project is we develop an app to try to predict batter and pitcher outcomes based on batters and pitchers in a matchup. So it's when you're watching baseball and you're thinking to yourself, should the manager pull this guy or pull this pitcher, or what's going to happen when this player and this pitcher and this hitter match up? We set to try to solve that problem by providing likely outcomes based on the matchup. Um, and so, in order to do that, we had to pull a lot of data. Our app will stretch back the last 3 years. It could be expanded beyond that, but for the sake of the app and the amount of data, we just wanted to do the last 3 years. Um, and in order to do that, we pulled data from StatCast um, for batters and pitchers the last 3 seasons, and we found the percentage of times, so like the rates for singles, doubles, triples, home runs, strikeouts, and walks. And once we found that, um, we decided we grouped all the stats so that we would be comparing players that have similar statistics in each category. So it's not necessarily fair really to compare or to treat a player that walks, say for the sake of the argument, 20% of the time with a player that walks 5% of the time. We don't want to treat them exactly the same. We want to treat them differently because they are. And we would do that with all of these statistics that we found. We would group them differently so that we can predict the total number, the true number of those outcomes. Um, so all those statistics, and then finding the true number, so the total number of walks, strikeouts, singles, doubles, triples, those rates over anybody that's within that same grouping. And we would do this for batters and for pitchers. And we wanted to keep everything have the same amount of responses or of live data for each pitcher and each batter. So we would take the top 500 from each season, and we felt like that was also enough of a data sample to really get some accurate results. And we did this for each season of each batter and each pitcher. So this will just be repeated 5 extra times, um, and then combined. And once we get down to the bottom here, they were grouped into one table with pitchers and batters based on those statistics. And we would create linear models to try to predict, to get coefficients to predict those statistics. And with walks, the coefficients that we found over here, we found that the R square value was 0.88. So decent predictive power, or I don't want to say predictive power, but decent explanation of variance there. For strikeouts, 0.91. That's the wrong thing. For singles, 0.91. Doubles, 0.89. Triples, 0.97. Home runs, 0.83. Hit by pitch, 0.89. And BABIP, batting average balls in play, 0.9, 0.90, 0.91. Um, and then we would take these values and use them to help predict outcomes. Now,
And then like the way we wanted to display the data, we felt like it would be easiest to make like a shiny app that could just like display everything. It'll be like interactive, so you can use it to like explore and it'll update everything on our own. So the way we went about this is I started creating like a data frame with like just placeholder values and zeros, and then just like gave them all the column names of all the like percentages of all the things that we're trying to find because it's just easier to like have the table and then just try and like update the values later instead of trying to create the table like within the app. So for the app itself, like the first part, we have like a navigation page that we wanted to create like two tabs. We just have like a part that's about like, or we have the app itself, which is just like the front page, and then we just also have like another tab that's just like an about, so people could like see that we made it and that there's like an explanation of what we were trying to do and like what's going on. So like moving on to just the app itself, it's got like or well, still the other part, I guess, is that
Sorry.
like we're just like trying to do the selecting the like inputs. We have like you can pick the better year, and then we have I mean because we use 2022, 2023, and 2024, so we have that for pick the better year and the pitcher year, and then I pulled the like batter and pitcher names from the data, and those are like interactive. As like what goes with the next part is you can see that like when I would like have it updated so that if the batter year or the pitcher year changes, it like can observe that event and it'll change the choices of the like batters and pitchers you can do. And felt like the easiest way to do that was just to sort them alphabetically. That was an easy way to do it so that you could like find anyone you're looking for. And then moving on to like the table itself, so like got the input of the batter and pitcher years that you take and their player names. So like filter all the data down to just the one batter and the one pitcher. And then from all the like equations that we found earlier, we were able to like plug it all in and obviously like I guess like put it like raise it up from like the power of e so that, like and then multiply it by 100 so we get like an easy percentage and it's like easier to read as opposed to any of the like log stuff that we were using to like better calculate it. And some of them were different, like the second base one and the like batting average of like the balls in play were better without like having a logarithmic like relationship, so those ones weren't exponentiated. So that was easier. I decided to just like round it off at two, so it was like a nice, just like easy number, which is clear and easy to see. And then once I got all those values, I added them into the, or I like made them a vector so that we could add them into the outcomes and display that as just the first row of the table so that it's easy to see. And now I guess we can like showcase the app.
Yeah. So running the app here, we get a default of CJ Abrams in 2022 and Corey Abbott in 2022. And we see based on their statistics from those seasons, this is the likely outcomes for that at bat. And just to prove that when we move it around, so let's go to 2023, still CJ Abrams, but let's do Cole Calhoun. I don't remember what team would have been at this point, but left-handed hitter, and then we'll do 2023 Shane Bieber. And based on that, we'll see that he had about a 21.5% chance of striking out in this matchup. Um, the goal on he's not going to hit a triple, but that makes sense because triples are very rare and very hard. And his batting average in balls in play is about 0.24. Um, and I mean, if we want to keep going around to Dominic Fletcher versus into different years, also it still works. Patrick Corbin, um, and it still moves around. Um, Yeah, and that's about it for the app. I did want to mention that we based some of our ideas for this app, this article that on Fangraphs from 2014, which we did our own research and we've created our own numbers from it. But this was a nice started to be a little bit of a framework to develop our idea, and yeah, and then he go this I believe it's Jonah Pemstein or Stein um, went through it and had the same question that we did about 10 years ago. And so we wanted to go through and kind of use this as a little bit of a framework as a justification really for some of the equations that we decided to run and to try to figure out. And yeah, it's a really good article. Yeah, that is our that is our app and our presentation. Thank you so much.
Yeah.